welcome back to part 7 of the motorcycle tank tutorials. I'm Alex Popov, a student of Learning Alias, and in this video we'll be building the blends between the top and side surfaces of our tank. Just uncheck symmetry from the layers tab. It's not needed at the moment, and close the view up a bit. And now we can build bi-rail surfaces to create the shoulder of our tank. So I just set the bi-rail tool to kind of default settings, degree 5 by degree 5 surface with positional continuity at all edges. And then I just change the rail edges to curvature afterwards, and then move on to the remaining surfaces to create our shoulder. And just quickly put these surfaces in. If you get any positional or curvature failures like this, don't worry too much about it. This surface, for example, I think we're just trying to ask to do too much work, so up the degree for now, and we'll come back and sort that out later. I'll also assign my planes to an invisible layer and continue around the rest of the shoulder in the same way. If I hit problems, I'll up the degree of the surface just to see if that fixes it. If it does, then I'll leave it there and come and rebuild the surfaces later, or if it doesn't help, then just knock the surface degree back to degree 5, degree 5. After finishing the surfaces, apply a shader, hardware shader, or the diagnostic shader here. And it's not a bad job at the minute, but we've got to realign the surface normals using the sector tool, and then the curvature evaluator shader will be readable. So we turn that on and slide the scale. A nice even red band running through the center line of the shoulder surfaces is a good result here, so that looks pretty good. And another way that we can check the curvature over our surfaces is by hitting new radial group in the cross-section editor, and then selecting the surface edges we want the cross-sections to run along. And then you can play with the number of planes that you want up here. Select nothing to get off the menu, and then reselect the surfaces and apply the cross-section editor. And again, the combs, they want to be as uniform and as smooth as possible. It shows good consistency over your surfaces. So we can just get rid of them and move on to fixing the problems that we saw earlier in the video. With the surface continuity evaluator selected, just double click it, and we're looking for curvature continuity, and we'll show the comb. Just hit on the surface boundaries, and where you've got problems it will be highlighted. So if we remember from earlier, not this surface was a problem. It had too many degrees, and so was, I think, that surface. First thing to do is put the controls back on the surfaces. We need to see what the CVs are doing, and then we can tell that it's degree 8 in the U direction for 2 of our surfaces. So we use the query edit tool to re-invoke the history, and we can play with the settings, see if we can help the situation at all. Try rebuilding from the edges, the rail edges as well. Sometimes Alias doesn't like to build surfaces from trimmed edges, so the rebuild option can help out here. Unfortunately not in this case, so we're going to have to break the surface up because it's doing too much work. A good way to rebuild your surfaces quickly and relatively accurately is with the extend tool. We want to select the options and extrapolate on, merge off, and then select the boundary here and drag to about halfway point. Now you want to turn merge back on and select the large surface and drag that back, and then snap to using Control Alt and click the surface boundary. We now have 2 surfaces, each with degree 8 in the U direction, so we can change that in the control panel back to degree 5. There we go. And with the evaluator, curvature evaluator, we can check for curvature now, which we have achieved. So there we go, problem solved. So I'll fast forward the video while I go and fix the final few surfaces. remembering to turn the degrees back down to 5 after we've separated them. And with these surfaces you'll see that when I check for continuity along the top edge we don't have it, so we use the align tool with partial option turned on and align the surfaces and everything's good. Turn the controls off and quickly fix this surface as well. Usually before splitting surfaces up using this technique, when we're trying to solve continuity issues, I would usually try direct modelling individual CVs or holes to try and gain the continuity that I was after. However, having done this model a few times, it turned out the surface was just doing too much work and needed to be split into 2 or more separate surfaces. So it was kind of a last resort. Always go for direct modelling first. The evaluator showed us we've got G2 continuity for the top and side boundaries of our shoulder surfaces. We now need to check for G1 or tangency continuity along the shoulder, so in this direction. Part of the construction requirements were curvature throughout the main surfaces and tangency on any sort of blends or fillets or rad surfaces. Some employers will ask for curvature throughout the model, some will only require tangency, but this was the requirements for this particular build. So you can see just using the transform CV control, and we can use move in NUV direction. When I'm deciding what way or what option I should use to pull my CVs, be it slide, NUV, XYZ or projected movement, I just kind of look at my hull structures and see what kind of movement I think would suit them best to keep them nice and uniform. So you can see here just pulling CVs until tangency is achieved. Don't do everything with one CV. There we go. The reason being is you probably break curvature along one of the other boundaries if you try to do it all with one CV. So a little bit here, a little bit there, minimises the risk of breaking continuity elsewhere. So you can see tangency has been achieved, and we can delete the history for the surfaces. With the diagnostic shader on, everything looks good. Yeah, and now the usual curvature evaluate shader. And finally we can use the cross-section editor. I still have that radial group saved, so it won't be all the surfaces for the shoulder line, but the majority of them you can see decent lead in, nice uniform combs. So I think we can be happy with that. So last thing to do before we have a complete solid volume for our tank is to intersect and trim the underside and blend surfaces. These ones. You can see I've intersected and I have one curve on surface, but I had a faulty curve on surface which I've deleted, but I'll just show you quickly what happened. I can extend with extrapolate and merge on the blend surface down a little bit until we get a nice clean curve on surface to trim to. The same thing happened at the other end actually, and a different way to fix this would be to project the surface edge of the blend onto the underside surface in the normal direction. If we put the deviation locator on, you can see that because the surfaces are so close together, projecting normal is okay, and we can then trim that surface. There we go. With the surfaces and the canvas image unhidden, you can see that the tank's starting to take shape. We now have a full volume, so we'll leave it here and I'll see you in the next video. Thanks very much for watching. I hope you found it useful.